Let's look at the elements of a percent sentence, and I've already talked a little bit about it. Here's the cast of characters. First of all, you have the whole thing, the original price, so forth. Then you have some part of the whole, and the third character in our cast is the percent, and that relates the part to the whole thing. Let's see how these things are hooked together. What we say is some percent of the whole is equal to a part, and that's the sentence that we need to identify. There are three basic elements that we look for. We have the whole thing, we have the part, and then we have the percent. These things are related to each other. We could, if we know any two of these, we can get the third, and there are three possibilities. There could be a missing whole, or the missing part, or the missing percent. We could have any one of those three things, but then we have to know the other two. If you know two, we can go and get the third. Let's talk about what the words mean, because if we're looking at English, we like to know how the words relate to the mathematics. Since we're going from English to math, let's look at our dictionary. When you see of in English, think times in math. As an example, 10% of 80 is 10% times 80. And when you do math with percents, you need to change them to a decimal. 10% of 80 is equivalent mathematically to 0.10 times 80. Is, of course, you've seen before, and that means equals. There's one other thing that we need to talk about when we look at these sentences. Typically in any sentence, so much percent of something else is a second number. It's easy enough in these sentences to identify the percent, but sometimes it's hard to tell in these references what's the whole thing and what's a part. There is usually an identification of the whole thing, because if you look for the word of, the quantity following that is generally the whole thing. As I've diagrammed on the slide, you can see these sentences will say a percent of the whole thing is a part. Look for anything after the of, usually to be a whole thing. Let's look at some actual examples. We're going to start with where we're given the whole thing, we're given a percent, and we find the missing part. And we remember that if we know two of these three things, we can get an equation that lets us work out the third. Here's our first example. 85% of 120 is what number? Guess what the whole thing is? The whole thing is 120. So we're given the percent, 85%, the whole thing 120, and we're asked to find what's left, what number, what part of 120 is 85%. Here's how we translate it. 85% of times 120 is equal to what number? That's our unknown n. We need to change the 85% to a decimal to do math with it. If you forget to do this, your number is going to be 100 times in error. Here's the change. 0.85 times 120 is equal to n. Then we do the math. 0.85 times 120 is 102. 102 is 85% of 120. 102 is the part. And usually when you express these things, 102 equals n is perfectly good mathematics, but often when you're dealing with an unknown, you say x equals something. In this case, I've just flipped it around to look like better math, n equals 102, but those two are really equivalent statements. Let's look at another example. 22.5% we're getting a little interesting here, of 34.6 is what number? We need to identify what's the whole thing, the number following the of. So 34.6 is the whole pizza, and we want to know what 22.5% of that is. We do the translation. Notice the of translates as a time sign. Now we need to change that percent to a decimal. We remember that 1/2 is the same as 0.5. We can change 22.5 or 22.5 to the decimal 0.225. Now we just need to do the mathematics, and when we do that, we can just use our calculators and find to the nearest 3 decimal places the part that we've calculated is equal to 7.785. That's our unknown. And again, if I want to, I can swap this around to make it look a little bit better. Let's look at one more example here. And in this case, we're going to use a very small percentage. 0.003% of 102 is what number? Same deal, we're given the percent and the whole thing, that number following the of, and we would like to know what the part is, how much the part is 0.003% of 102. When you see a number like this, and you do that translation, you have to be careful because that's not a decimal, that's a percent. You see that percent sign there. What we need to do is change that percent to a decimal, and so it's going to be even a smaller number. Remember how we do this. We put in a bunch of zeros in front of the percent. Look at where the decimal point in the percent is and move 2 places to the left. We've translated that then to 0.00003 times 102 is equal to n. When we actually go here and do the math, we find that actually n is a very small quantity, as we'd expect it to be. N is 0.00306, a very small part of the whole number, which is 102. And again, if I wanted to, I could flip this around just to make it look nice. It's only cosmetics. It doesn't have anything to do with the math. But typically, if you're expressing an unknown, you usually say the unknown is equal to something, just more or less convention, nothing more. Perfectly okay either way because, of course, things on either side of that equal sign are equivalent to each other. Let's try something with actual units in it. 15% of $12.35 is what number? We'll translate this to an equation. 15% times $12.35 is equal to n. 15%, when I see 15%, I think of, for example, a restaurant bill, a restaurant check, and the tip is often 15%. Perhaps this is a useful calculation. Again, we change the percent to a decimal, and I have 0.15 times $12.35 is equal to n. I use my calculator and work this out and round this off to the nearest hundredth because that represents dollars and cents, and I find a 15% tip of $12.35 check would be $1.85. N is equal to $1.85. Now, you may not carry a calculator with you, and this is such a useful idea that let me show you a shortcut that I learned to calculate tips at a restaurant. Here's a typical situation where at the restaurant I get a check for $43.78, and what I need to know is how much of a tip should I leave? And we all agree that for decent service, a typical check would be 15%. Let's look at what is 15% of $43.78. Here's a good way to do it. I remember that 15% really means 10% plus 5%. It's relatively easy to take 10% of $43.78. You just move the decimal point one place to the left. 10% of $43.78 is $4.38, rounding to the nearest penny. 5% is half of 10%. I can do that in my head. Half of $4.38 is $2.16. 15%, I would just add those, $4.38 and $2.16. Here's the rules. You move the decimal point over one place to get 10%, take half of that, and then you can estimate. 438, 216, a little bit hard to do. Let me round the 438 up to 450, and then round down the 216 to 2. In my head, I can do that math and understand that of the $43.78 restaurant check, I need to leave a $6.50 tip, given, of course, that I was satisfied with the usually excellent service you find at restaurants. Let's look at another one. We're at a diner, maybe for breakfast, and the check is $8.40. Let's use that same procedure to calculate the 15%. First, we calculate the 10% and moving the decimal point over to the left one place to get 0.1 times 8.4. That gives me 0.84, so 84% is 10%, and we can round that off to about 90. Then half of 0.84 is 0.42, round that off to about 0.4, and we see that we've estimated the tip at $1.30, and of course it's always nice, if you're not sure, to throw in a little bit extra, because these people typically work very hard for you, and these days 15% is pretty standard, or even on the low end. If you want to add a few cents more, I'm sure the wait people would thank you for it. Now let's go to another situation where we use percents and try to find the part. And this is always the sad case. You've struck a great deal on a new car, you think you've gotten a very good price, and then they add in the sales tax. And typically in Tucson, they add in around a 7% sales tax. We want to find out what that tax is. What we want to do is find 7% of $24,599. We translate this to a simpler equation, and we can say 7% of $24,599 is how much. From here we can go to the math. 7% is 0.07 of times. Notice that right after the of is the quantity, that's the whole thing, is equal to how much, what number. Now we have the equation. We can go here and solve that equation, and I find that the tax I need to pay on an approximately $25,000 car at 7% is about $1,700. So really what we're talking about here is the cost of the car to you out the door, as they say, is actually going to be the price of the car plus the tax. Really, when we calculate how much we're paying for the vehicle, we have to throw that tax in, and so our $25,000 car is really costing us $26,320, and of course you can often negotiate out that 93 cents, and they're being very generous. Well, I'm being a little bit sarcastic, I guess. Never mind. Let's look at another possibility. Suppose now you're given the part and you're given the percent let's look at situations where you would calculate the missing whole piece. You know 2 pieces, you can calculate the third. Let's look at what one of those sentences might look like. Given the part and the percent, we're going to find the whole thing. 10% of what number is 20? Notice that right after the of, we have something we don't know, but we're given the piece of it that's 10% of it. Let's translate this into an equation. 10% of what number equals 20? Now we can do the math, but of course first we need to change the 10% to a decimal. I get 0.10 times n equals 20. There's an equation. 0.1 n equals 20. How do you usually handle these equations? We need to get n by itself. When I do this, I need to divide both sides of that equation by 0.10. When I do that, I have n then is equal to 20 divided by 0.10. When I work this out, it's equal to 200. I notice something else here. When you divide by a number less than 1, what you get is bigger than the original number you started with. 20 divided by 0.1, a number less than 1, is equal to 200. Let's look at another example. 22% of what number is 67? Let's translate this to an equation. 22% of what number equals 67? We're not done. You have to be careful. It's not 22 times n. It's 0.22 times n is equal to 67. Now that we've translated it, we have done most of the work. The rest is relatively straightforward. We need to get n by itself. I divide both sides of that equation by 0.22. I find that I wind up with n is expressed as 67 divided by 0.22. When I work this out with my calculator, I find that n is equal to 304.5454545454. I can express it this way, or I could round it off if I'm going to use it in some further calculation. 55 is 23% of what number? Let's take a look at this. So 55 is 23% of what number? We've switched the sentence around a little bit, but it means exactly the same thing, except now we have the part on the left. Remember, we can turn this around. The is equivalent to the equal sign. 23% of what number is 55, or 55 is 23% of what number? That'll work either way. Here's the translation. 55 is equal to 23% times n, changing the 23% to a decimal, and solving the equation, dividing both sides of the equation by 0.23, the decimal equivalent of 23%. When I work that out, I get that n is close enough, rounding off, to 239.31. And as I said, I could express it that way just because it looks nicer mathematically. Let's look at another one using some larger numbers, and we have to take a look at this because what are we really talking about here? 26,320.93 is 107% of what number? Up to this point, what we've looked at is where the parts are smaller than the whole. But what does that 107% say? 107 means that that's bigger than the whole number because it's more than 100%. If we translate this, what we find is 26,320.93 is 107% of what number? Let's work that out. We change the percent to a decimal, then solve that as an equation. We divide both sides of that by 1.07. When we do, we find that n is 24,599. Incidentally, do these numbers look familiar to you? These are the numbers I've used in the car example. I started with a car worth $24,599. When we add the tax in, we found it was $26,320. That turns out to be 107% because remember we had the 100% from the price of the car and the 7% sales tax. 107% is the whole price of the car plus 7% sales tax. It's interesting how that works out. In this example, I've done something math teachers might do to try to fool you. 0.03 is not 45%, but 0.45% of what number? We translate this into a sentence, but we have to be careful because that's not 45%, that's 0.45%. When we change that to a decimal, we need to remember we have to start at the decimal point, and to get the decimal equivalent of 0.45%, move the decimal point a couple of places to the left. When we do, we get the equation 0.0045 times the whole number is equal to 0.03. Now that we have this equation, we can do the math, divide both sides by 0.0045, and when we do this, we find that n is equal to 5.66666, which, remember, we can put a bar over to indicate that is our final result. We have one more combination left. At this point, suppose we're given the whole and the part, and we want to find what the missing percent is. We're given whole and part, and now we want to find the third thing, the percent. Here's what a typical sentence might look like. What percent of 300 is 100? Here's how you would express it. What percent, that's our unknown, let's call that P, of times 300 is 100. Now we have this equation, 300p is equal to 100. To complete the problem, we need to solve the equation 300p equals 100. We need to get p by itself, so I divide both sides of the equation by 300 and get p is equal to 100 over 300. I see two zeros in the top, two zeros at the bottom. If I divide the numerator and denominator by 100, it's the same as canceling those zeros out. And I see that p is equal to 1/3. P needs to be expressed as a percentage, and I may remember that 1/3 is equivalent to 33 1/3%, but if we want to, we can work that out by dividing 1 by 3, and we get 0.33333 that just keeps repeating. If I change that to a percent, I move the decimal point 2 places to the right, and I finally find that P is equal to 33.333333%, or I can write that as 33 1/3%. My sentence then would become, in substituting the 33.3% in for what percent, 33 1/3% of 300 is 100. Here's another example. What percent of 250 is 1,500? I translate this into an equation. What percent, that's my unknown, of the whole is equal to 1,500. Here we go. 1,500 is the part. Now this might be a little bit interesting. 250p is equal to 1,500. Now we work this out by dividing both sides by 250, and I find that then P is equal to 1,500 divided by 250. Notice something interesting has happened here. Look at that fraction. That's an improper fraction. Think about what kind of a percent I'm going to get from that. Always try, as you work on this, to look at what's happening and think ahead a little bit. I notice I have a 0 in the 250 in the denominator, and I have a 0 in the numerator. Let me cancel those things out, divide both sides by 10 if you will, and I find that 150 divided by 25 is equal to 6. P is equal to 6. That's not expressed as a percent. Remember, to express it as a percent, we have it as a decimal. To move that decimal point 2 places to the right, and I finish by saying that P is equal to 600%. Repeating that original sentence, 600% of 250 is 1,500. Maybe math teachers like to present problems that seem difficult or hard. For example, now I'm looking at fractions. What percent of a half is a quarter? That doesn't look like any of the numbers I've dealt with before, but if you stay calm and just follow the procedure, everything will work out fine in the end. Let's translate this. What percent P of 1/2 is equal to 1/4? I finally get the equation 1/2 P equals 1/4. Let's see how to solve that equation. If I need to get P by itself, I multiply both sides by 2, and I find then that P is equal to 2/4, in lowest terms, 1/2. In order to change P to a percent, I remember that 1/2 is equal to 50%. If I didn't remember it, I could divide 1 by 2, get the decimal, and then change it to a percent.